Chapter 11, Section 4 in the 8th grade note-taking guide is entitled Solving Inequalities by Multiplying or Dividing. So remember, solving inequalities is done the exact same way that we solve an equation. All of those rules that we've been using for the last 2 years for solving an equation are exactly what I'm going to do here when I solve an inequality. Now, as far as solving an inequality goes, there's really only two other little pieces I have to remember. I have to remember there's that little trick rule that I sometimes have to use if I end up multiplying or dividing by a negative. If I were to end up multiplying or dividing by a negative, remember that flips the direction of the inequality sign. And that's not me telling you something new. We've actually already done that. That should be more of a reminder than me telling you something new. We also have the graphing step, graphing the inequality on the number line. Remember, the graphing the inequality is a visual way to show all the solutions that match up with the inequality. So in part A here of number 1, we've got 12 is less than a over 4. Now you know I would never solve that question that way, because if I was doing solving an equation, the variables would have to be on the left. So of course I'm going to flip this around and get the variable on the left, which is exactly where I have to start here. So I'm going to go ahead and flip this around and write this as a over 4 greater than 12. Now as far as me flipping that around goes, remember when I flip these guys around here, the alligator still has to eat the same thing. It's not like an equal sign where the sign is the same either way. Here, this is showing me that a over 4 is larger. When I flip it around, I still want to make sure that what I'm showing you shows a over 4 as being larger. Alright, so let's solve this. Keep the variable on the left, send the numbers to the right, so we know we have to move the 4 here. So what am I going to do? I'm going to multiply both sides by 4. Alright, so here I'm going to be left with a, which is great because I want the variable by itself on the left side, and it's going to be greater than 48. So that's my solution to my inequality. A is greater than 48. Now I want to go ahead and graph that on the number line. Now as far as graphing that on the number line goes, hopefully you remember there's different dots that mean different things. If I have a question with greater than or less than, that gets put on the number line with an open dot. If I have a question with greater than or equal to or less than or equal to, those get put on the number line with a closed dot. So since this one is greater than, I'm going to put an open dot on the number I have in my inequality, the only number I have in my final solution here, 48. Then I'm going to shade from the dot to the right. Remember, the whole reason that we've spent the better part of 2 years solving equations with the variable on the left is for this very topic. Because once I have the variable on the left in an inequality, the shading on the number line goes the same direction that the sign points. If it points to the right, we shaded from the dot to the right. As far as that step goes as well here, remember it matches up with what this says, because the shading says what this says. It says the solution here, whatever a is, has to be bigger than 48. Numbers like 49, 50, 51, and 52. Well, what's shaded here? Numbers like 49, 50, 51, and 52. As far as the check goes here, which is what they're then talking about, you can now check your inequality with anything that's in the shaded region on the number line. So you can check it, and you should get a true statement whether you test 49, 50, 51, or 52, or 53, because those would all fall in the shaded region of the chart. If we tested a number that wasn't in that area I shaded, like 43 or 44 or 45 or 46, I'm going to have problems because that was not a solution based on the number set that we were given. So here when they test it with 49, 49 divided by 4 changes into 12.25. Well, 12.25 is bigger than 12. So 49 is a logical solution to the inequality. On the other hand, if I test it with 47, which was not in the shaded region, 47 divided by 4 is 11.75. Well, based on the way that one's written there, that obviously is not going to work. 12 is, in this case, not smaller than 11.75. So 47 here ends up being not a solution. Obviously, the statement that we've generated here, once I fix their little typo there, 11.75 is not bigger than 12, as the question says. So here with part B now, negative 9b less than or equal to 45, well, let's run the same list of rules that we've been using here. Multiplication problem gets solved with division, as you know. So I'm going to go ahead and divide at this point, divide both sides by negative 9. When I divide by negative 9, I do get b, that's good. I do get negative 5, that was expected. What you have to remember, though, is this is that one that uses that little special rule. The rule that says when we multiply or divide by a negative, flips the direction of the inequality sign. Here, I divided by negative 9. Because I divided by a negative, that's going to flip my inequality sign around. So it's not going to point to the left like the original one did anymore. Now it's going to point to the right. So we end up with b is greater than or equal to negative 5. A closed dot on negative 5 with shading taking me to the right. All right, here's number 2. Number 2 says a rock collecting club needs to make at least $500. They're buying rocks for $2.50 and selling them for $4. What is the least number of rocks the club must sell to make their goal? So we're going to fill in the important information here. The answer is the number of rocks the collecting club has to sell to make $500. They need to make at least $500. They're buying the rocks for $2.50 and they're selling them for $4. So what they're going to do is take that information and turn it into a statement to help us find the profit. If they're selling them for $4 and buying them for $2.50, their profit on each rock is $1.50. So that's going to be how we're going to generate our inequality here, by taking $1.50 and multiplying it by the number of rocks that we're going to sell, which is called x. Obviously, that's our unknown, so that's our variable. That's what a variable is. It's something we don't know. In order to turn a profit here, or at least in this question to make their goal, they have to sell $500 worth. So they can sell exactly $500 or more than $500. So that's why they wrote greater than or equal to, because it can be exactly $500 or an amount bigger than $500, which satisfies the inequality here. So, as we go about solving this question here now, solving this inequality, we use our rules. Our rules tell us to keep the variables on the left and keep the numbers on the right. Well, that means x being on the left side of the inequality is good, 500 being on the right side of the inequality is good, $1.50 being on the left is bad, because that's a number and it's supposed to be on the right. So I'm going to move that, and again, whenever I move something, I do the opposite. So the opposite here is going to be to divide by 1.5. 500 divided by 1.5 is going to give me the solution I need here. 500 divided by 1.5 changes into 333.3 repeating. Now, obviously, I can't sell 333 1/3 rocks, so I can't round down, because 333 isn't going to give me enough, because again, I had to have 333 1/3 just to get to 500. So that means at least 334 rocks are going to have to be sold to make the sales goal of $500. Selling one rock, as we know, would make $1.50 for the club. And if I multiply that by 334 to verify my solution, $1.50 times 334 is 501. And indeed, that vets out exactly how we expected. 501 is the amount I needed. 501 will get me over the amount I needed by $1. So in the last one, we're going to solve and graph 12 is less than or equal to negative 4a. So as far as solving this one goes, of course, I'm going to flip this around because you know I want that variable on the left side. And again, remember, as far as flipping that around goes, keep that sign flipped with the same representation. Here, it was saying that negative 4a was larger. When I flipped it around, here it's having the same representation, showing me that negative 4a is larger. Solve, keep the variable on the left and the number on the right. So that means I've got to go ahead and get rid of the negative 4 here. This is a multiplication inequality, so I'm going to solve by dividing by negative 4 here. When I divide across by negative 4, that's going to give me a, of course, and negative 3. But again, I have to remember that little trick rule here because I divided by a negative. It's going to flip the direction of my inequality sign. So we're going to say a is less than or equal to negative 3. Graphed by putting a closed dot on negative 3. Closed because it's one of the ones that has the line underneath it. And by shading to the left. The same way the sign points, which would correspond with the same solutions. The numbers that are smaller than negative 3 are negative 4, negative 5, negative 6, negative 7. Where would be those compared to negative 3 on the number line? To the left of negative 3 on the number line.